In this video, let's explore O-Level 2021 Additional Math Paper 2. Let's take a look at the first question. Okay, this is the first question. And in this question, we are given an equation. This equation, let me write it down here. So in question number 1, we are supposed to solve this equation. 3e to the power of x plus 5. This is 2e to the power of minus x. According to the question, we will be expecting just one solution. And for that solution, we are supposed to find it and correct it to two significant figures. So for this that we have here, I'm going to try to change this. So this is 3e to the power of x plus 5. This is going to be 2 over e to the power of x. So I'm going to multiply this equation throughout by e to the power of x, which will give me a 3 e to the power of x multiplied by e to the power of x, e to the power of x squared, plus 5e to the power of x is equal to 2. And I'm going to bring that 2 over to the left-hand side, so I will have a minus 2. And since now in this equation here, we have a consistent e to the power of x, I'm going to let this variable, e to the power of x, be just represented by u. So u is equal to e to the power of x, which means that this equation will now become 3u squared plus 5u minus 2. This is equal to 0. Let's factorize this quadratic equation. So factorizing this gives us a u plus 2. Then this we have a 3u minus 1. This is equal to 0. So u will be minus 2 or u will be equal to 1 over 3. U is equal to minus 2 means e to the power of x is equal to minus 2. And this is impossible because e to the power of x by itself is always going to be positive. That is why we have to reject this as going to be the equation that is going to get us a solution for x. So we have this, which means that e to the power of x, this is equal to 1 over 3. If I were to ln both sides, we will have a ln e to the power of x is equal to ln 1 over 3. X, I can bring it forward. We will be left with a ln e, which is 1. So x is equal to ln of 1 over 3. And this shows that the equation has only one solution, and we're supposed to find this solution, right? So to find this solution, let's try to evaluate this and correct it to two significant figures. Pressing into the calculator gives me a negative 1.1. So this is question number 1. Let's move on and take a look at question number 2. And in question number 2 here, we are supposed to show that x is equal to minus 1 is the solution to this equation. On the left-hand side, we have a polynomial. And for this polynomial, I'm going to let it be equal to fx. So fx here will be equal to now 3x to the power of 3 plus 4x squared minus x minus 2. This is the left-hand side of the equation. So in order for me to show that x is equal to minus 1 is a solution to that equation, when I substitute minus 1 into this, we will be expecting a 0. Let's see whether we're going to get that, because if that is happening, then x is equal to minus 1 is the solution. So this is equal to 3 minus 1 to the power 3 plus 4 minus 1 square minus x is going to be replaced by minus 1. So here is minus 1, then minus 2. So we have a minus 3 plus 4 plus 1 minus 2. And this is equal to 0. Okay, so therefore we can say that x is equal to minus 1 is the solution to this equation over here, which is 3x cubed plus 4x squared minus x minus 2 is equal to 0. And hence we are supposed to solve this equation completely. So in order for me to do that, okay, I'm going to let this fx, which is equal to this, which is 3x to the power 3 plus 4x squared minus x minus 2. I'm going to let this be its factorized form. And we know that x is equal to minus 1 is a solution. So by using the factor theorem, we know that x plus 1 is going to be a factor. The other factor is going to be a quadratic factor. Why? Because this is x to the power of 3, and this we have a linear, which means that here we will be expecting a quadratic factor, so that when I multiply it to this, it is going to give me a x to the power of 3. So I'm going to assume this quadratic factor to look like this. Ax squared plus bx plus c. And if you to observe this on the right hand side, we can actually see that a, when I multiply this to this, it is the only way that I can be getting a 3x to the power of 3. So if this were to be multiplied to this, where the coefficient is 3, that means 1 times a, it has to be equal to 3. So a, by observation, we can see that a is going to be equal to 3. In fact, we can also observe another coefficient, which is c. So a is equal to 3, c is going to be equal to, if I were to take this, multiply by this is the only way that I can get the term that is independent of x. So the term that is independent of x is minus 2. 1 times c gives me minus 2. This means that c must be equal to minus 2. So now we have, okay, let me just rewrite this, okay? So now we have fx, which is equal to 3x to the power of 3 plus 4x squared minus x minus 2. This is going to be x plus 1. A is 3. So this plus b, okay, we still have yet to get b, then this is minus 2. In order for us to find the value of b, I'm going to do one more comparison. I am going to pick minus x here for me to do a comparison, the term that is the term that is of x. So I'm going to look at the term that is of x. Specifically, I'm going to look at the coefficient. The coefficient of the term that is of x. So if I were to look at the coefficient of x, on the left hand side here is minus 1. And on the right hand side, how are we going to be getting x on the right hand side? It is going to be taking this multiplied by this. So x multiplied by c, so this multiplied by this, the coefficient is minus 2. And this multiplied by this. So 1 multiplied by bx, the coefficient is b. So looking at this, we can see what is b. b here is going to be equal to 2 minus 1. So b is going to be equal to 1. So therefore, now we will be able to find fx in its more factorized form, which is equal to this. So we have x plus 1. Then after that, it is going to be 3x squared plus b, which is now 1. So this minus 2, and this is supposed to be equal to 0. Let's factorize this further. So this is x plus 1. Factorizing this, we will be getting a 3x minus 2 and x plus 1. This is equal to 0. We have a repeated root over here. I'm going to combine this to become x plus 1 square. Then 3x minus 2, this is equal to 0, which means that x is going to be equal to minus 1. This is one of the solutions. And the other one is going to be when x is equal to 2 over 3. Okay, this is question number 2. Let's move on to question number 3. In question number 3, part A, we have a differentiation to do. So we're given that y is equal to x over this 2x plus 1 to the power of half. So to find dy dx, let's make use of the quotient rule. It is going to be equal to the denominator. I'm going to write it as it is. Differentiating the numerator, it is equal to 1 minus away differentiating the denominator, which is going to be half 2x plus 1 to the power of minus half. Chain rule, I will be differentiating 2x plus 1. This gives me 2. Then I will multiply the numerator. This is going to be divided by the denominator square. So we have a 2x plus 1 to the power of half. This thing here square. So this is equal to, okay, this is equal to square root of 2x plus 1. Then 2 and 2 can be cancelled. I will have a minus x. This negative here as the indices, I'm going to bring it down. So we will have a x over square root of 2x plus 1. And this is going to be divided by 2x plus 1. So I'm going to try to combine the numerator into one single fraction, which is going to be equal to this multiplied by this, which gives me just simply a 2x plus 1. Then minus away x divided by this denominator, which is going to be square root of 2x plus 1. And let's not forget about the original denominator. So we have a 2x plus 1. And this will be a 2x minus x. It is going to give us an x. So we have x plus 1 divided by this and this. I'm going to just combine it in the denominator. I'm going to rewrite this as 2x plus 1 to the power of half multiply by another 2x plus 1. So what I'm getting here is x plus 1 over 2x plus 1 to the power of, combining the two index together, 1 over 2 plus 1. This gives me a 3 over 2. So this is part A. We are going to be making use of part A, which we have actually shown what the question wants us to show. So we are going to make use of this to try to do part B because it is a hence. Okay, so we're going to make use of this result. Let me write down the result here, and before I erase it. So this is what we have shown so far. We have shown that when we try to differentiate y is this x over 2x plus 1 to the power of half. When we try to differentiate this dy dx, we are getting this. So this is equal to this x plus 1 divided by 2x plus 1 to the power of 3 over 2. Let's make use of this to do part B. So from part A, we have gotten this. So if I were to work on part B, which is an integration question, and integration is supposed to be reversing the process of differentiation. So if I were to do that and applying an integration to the right-hand side and the left-hand side, on the right-hand side, I'm going to write down this, okay? If I were to be integrating this from 0 to 4 of x plus 1 over 2x plus 1 to the power of 3 over 2. Then it will reverse back the process of differentiation, which will be giving us x over 2x plus 1 to the power of half. And let's not forget that we are applying a definite integral over here. So this is going to be from 0 to 4, which we are going to be substituting in later. So let's continue to integrate this. And why is this good? Because according to what we have in the question, we have a x over 2x plus 1 to the power of 3 over 2, which we are supposed to evaluate. And we can actually find that within here by breaking this up into two parts. Let me show you. So if I were to break this up, 0 to 4 of x over this. So we have a x over 2x plus 1 to the power of 3 over 2. This is one part of the integral. And 1 over this. I'm going to make it into the other part of the integral. So 0 to 4 of 1 over 2x plus 1 to the power of 3 over 2. This is going to be equal to this. We can evaluate this later, or we can just evaluate, maybe let's evaluate it now. Okay, so substituting 4 in, we have a 4 over 2 times 4, 8 plus 1. We have a 9 to the power of 1 over 2. Then minus away, substituting 0 in is just simply going to be equal to 0. So this here is going to be equal to 4 over 3. So this is what the question wants me to find. I'm going to bring this over to the right-hand side. So we have integration from 0 to 4 of x over, this is 2x plus 1 to the power of 3 over 2. This is going to be equal to, we have a 4 over 3 here, right? So it is going to be 4 over 3 minus away integration of this from 0 to 4 of this. Okay, I need to prepare myself for integration. So I'm going to just simply rewrite this now. To integrate this, I think it is easier for us to see it as this to the power of minus 3 over 2. So we have this. So this is going to be equal to 4 over 3 minus away. Integrating this, it is going to be 2x plus 1 to the power of this plus 1. So we have a minus 1 over 2 divided by the coefficient, which is 2. Then after that, minus 1 over 2. Let's not forget about the definite integral from 0 to 4. So here, 2 and 2 can be cancelled. We have a minus 1. I'm going to just bring this minus 1 out. So we have a 4 over 3 plus. Now we have this 2x plus 1 to the power of minus 1 over 2 from 0 to 4. This is equal to 4 over 3 plus 4. Substituting it in, we have okay, this is actually 1 over square root. So it is going to be 1 over square root of 2x plus 1. Substituting 4 in, we have a 8 plus 1, so square root of 9. Minus away 1 over square root of 1. So evaluating this, we have a 4 over 3 plus, this is 1 over 3, then minus 1. My answer here is equal to 2 over 3. Let's move on. Let's take a look at question number 4, which we have a diagram here. Okay, let's take a look at this. Okay, this seems like an R formula question. So we are supposed to, in part A, show that the height is equal to this expression 6 sine theta plus 4 cosine theta. So the height h is actually the distance that c is above the ground. So it is this vertical distance here. We can definitely draw one vertical line down, or if you can just change your perspective a little bit instead of just directly going from C down. What if we were to draw a right-angled triangle here? So here, and there's a right-angled triangle here. And if I were to just continue to go vertically down, we have another right-angled triangle here. And this distance here will also be h. I'm going to name the corners, okay, so it is easier for me. So it will be D here, and I'm going to choose this portion here, this point here to be E. So what I'm going to try to do to find H is to try to find BD, and I'm going to try to find BE, because these should add up together to give me H, right? And the good thing is we have two right-angled triangle here. So for this two right-angled triangle, I am going to let, okay, the question is already given to us that this angle here is theta. In fact, we know another angle is going to be equal to theta, because if this plus this plus this is 180 degrees, this plus this plus this is also 180 degrees because they're on the same straight line. That makes this angle here also the angle theta. So what we are going to do is we're going to make use of Topical and to try to find this BD, involving BD, because that is going to be giving us H. So making use of this, we are going to look at, we know that this angle CBD is equal to theta now. So let me write it down. Angle CBD, this is equal to theta, and going for this triangle here, we are going to make use of cosine so that I can involve the distance BD. So cosine of this angle theta, this is going to be equal to the adjacent, which is BD, over the hypotenuse, which is 4. This tells me that the length BD is going to be equal to 4 cosine theta. As for this triangle over here, I'm going to make use of sine. So sine theta is going to be equal to the opposite. Okay, so I can involve a length that is going to give me H. Opposite, which is going to be BE, opposite over the hypotenuse, which is 6. This tells me that BE over here is 6 sine theta. So we know what is H. H is going to be equal to this BD plus BE. So H is going to be equal to this, which is 4 cosine theta, plus BE, which is 6 sine theta. And of course, if we were to try to compare to what the question wants us to show, we just need to rewrite this as 6 first. So 6 sine theta, then plus, then after the 4, so plus 4 cosine theta. Okay, this is what the question requires us to show. And in part B, we are going to try to re-express this into its R formula form. So from part A, we have gotten and shown that H is equal to 6 sine theta plus 4 cosine theta. And in part B, we are supposed to re-express H into the form of R sine theta plus alpha, where R is a positive number and alpha is between 0 degrees and 90 degrees. Let's expand this using trigonometric identity. This is going to be equal to sine theta cosine alpha plus cosine theta sine alpha. And if I were to multiply R in, we have a R sine theta cosine alpha plus R cosine theta sine alpha. So if I were to compare this H to this version of H, we can see sine theta and sine theta here, which means that 6 is going to be equal to R cosine alpha. Let me write it down. So R cosine alpha, this is equal to 6. I'm going to call this equation number 1. And if I were to compare this to this, that means R sine alpha, this is going to be equal to 4. I am going to call this equation number 2. Let's try to make use of these two equations to solve for R and to solve for alpha. I think alpha seems to be pretty easy because I can just make use of equation number 2 and I divide this by equation number 1. So this will be R sine alpha divided by R cosine alpha, which is going to be equal to 4 over 6. And RR can be cancelled. Sine alpha divided by cosine alpha gives me a tangent. alpha is equal to 2 over 3. This tells me that alpha here is just simply equal to tangent inverse of 2 over 3, and since alpha is an angle that is between 0 to 90 degrees, it is just going to be an acute angle that is in the first quadrant. Pressing this directly into the calculator gives me a 33.690 degrees. So this is alpha. Let's try to solve for r. To solve for r, I am going to take equation number 2. I will square it and I'll add it to equation number 1 square. Equation number 2 square, on the left hand side, we will have a r square sine square alpha. And here it is going to be a r square sine square alpha is equal to 4 square plus 6 square. And that means r square multiplied by, if I were to factorize r square, we will have a sine square alpha plus cosine square alpha. This is going to be equal to 4 square plus 6 square, and this is equal to 1. So r square is equal to 4 square plus 6 square. This tells me that r, which is a positive number according to what the question says, r is going to be equal to the square root of 4 square plus 6 square. Okay, let me just write it down. 4 square plus 6 square. So r is going to be equal to square root of 52. Therefore, we can now write down h. H, according to the form that we have just derived based on the value of r and alpha, h is going to be equal to r, which is square root of 52, then sine theta plus alpha to 1 decimal place. This is 7.7 degrees. Okay, let's look at the last part, part C. From the previous part B, we have h is equal to this, and I'm writing this to 5 significant figures, okay? So we are supposed to find the value of h and the corresponding value of theta if C is at the highest possible position. And h is equal to this. For C to be at its highest possible position, h is going to be the largest possible also, and this is actually the amplitude of this. So the highest position of C will be when h is equal to square root of 52. So this represents for us the highest possible position of C. And what is the corresponding value for theta? That is when this is equal to 1, right? Because sine is always going to be between -1 and 1. So when it is at its maximum, which is 1, so 1 multiplied by this gives me the maximum possible h, which is going to be the highest possible place for C. And the other one is definitely like what we have just discussed, to be letting this plus 33.690, I'll be letting this be equal to, okay, not 0. I'll be letting this be equal to 1 for the highest possible C to be happening. So I'm going to be letting this be equal to 1, which means that theta plus 33.690 degrees, this is going to be equal to 90 degrees. This gives me the value of theta to 1 decimal place is 56.3 degrees. Okay, let's move on to question number 5. Okay, let's take a look at this question. Okay, let's check out question number 5. So far, it seems like the questions are getting longer, and question 5 is also pretty long. It has 3 parts. So the question tells me that y is equal to 2x squared minus 6x plus 3, and in part A, we are supposed to find the set of values of x for which the curve lies above the line y is equal to 11. So for the curve to be lying above the line y is equal to 11, that is when y is going to be bigger than 11. So we are going to be letting 2x squared. So here is, we are going to be letting this y, which is 2x squared minus 6x plus 3 be bigger than 11. We're going to try to solve this quadratic inequality. So this is going to be 2x squared minus 6x. Bring 11 over to the left-hand side. We have a minus 8. This is bigger than 0. Let's divide this throughout by 2 first. So we have this minus 3x minus 4. This is bigger than 0. Factorizing this, we have a x plus 1 multiplied by x minus 4. This is bigger than 0. We can draw a quadratic graph that represents the left-hand side of this. So for this, we will have 2 places where this y is equal to this. We're cutting x, which is going to be at -1 and 4. So we are looking for the portion which is bigger than 0. So the portion that it is bigger than 0 is going to be this portion and this portion. So Therefore, my answer is x is supposed to be less than -1, or x is supposed to be bigger than 4. And for this set of answer that we have here, we are supposed to represent it on a number line. Okay, I guess that is easy. So if I were to draw a number line for x values, we will have -1, we will have 4 here. It is strictly less than -1, so I'm going to use a hollow dot and it will go all the way to the left. It is strictly bigger than 4, so I'm going to use a hollow dot here and I'm going to go all the way to the right. Okay, let's move on to B. And in B, we have another line over here. This other line is the line y is equal to 2x plus k. So according to the question, this curve that was given to us in the previous part and now this line, they are tangent at the point P. We are supposed to find the value of the constant k. So in order for them to be tangent, they are touching each other, which means that when I solve simultaneous equation for these two equations, we are going to be expecting one solution. So let's try to solve the simultaneous equation first. I'm going to call this equation number 1 and I'm going to call this equation number 2. So for part B, the first thing that I'm going to do is I'm going to equate equation number 1 to equation number 2. So we have a 2x squared minus 6x plus 3. This is equal to 2x plus k. So 2x squared minus 6x minus 2x plus 3 minus k is equal to 0. We have a 2x squared minus 8x plus 3 minus k is equal to 0. And just like what the question has mentioned to us, this and this, they are supposed to be tangent to each other. So as I solve the simultaneous equation, we will be expecting one solution. So now we have a quadratic equation, and for this quadratic equation, we are expecting just one solution. I'm going to apply the discriminant, because for this equation to have just one solution, we are going to be letting the discriminant be equal to 0 in order for it to have just one solution. So the discriminant is going to be equal to b squared minus 4ac. So this is equal to 0. Okay, we can actually just solve for k directly. We have we will be getting 8k. This is going to be equal to minus 40. So k here is going to be equal to minus 5. And for this value of k, we are supposed to find the coordinates of p. And p is the place where this and this, they are going to be intersecting. So let's just continue directly with part C to find the coordinates of p. So in fact, when I try to solve this as a solution, to solve this as a pair of simultaneous equation, we will be getting this, which means that this equation here will be that equation that is going to be giving us the coordinates of, the x coordinates of p. So let's just substitute minus 5 into here. So we have a 2x squared minus 8x plus 3 minus k, which is equal to minus 5. This is equal to 0. So we will be getting a 2x squared minus 8x plus 8 is equal to 0. So okay, we can simplify this. So let me just do a quick simplification by dividing this equation throughout by 2. So we have this plus 4 is equal to 0. So we have a x minus 2 squared. This is equal to 0. So we know that x is equal to, no, not 0. X is going to be equal to 2 at the point P. So when x is equal to 2, we can substitute it back into here to find y. So let me just do it here. So when x is equal to 2, y is going to be equal to 2x plus k, which is minus 5. So y is going to be equal to minus 1. Therefore, the x coordinate of p is 2 and the y coordinate of p is minus 1. Let's take a look at question number 6 then. Okay, this question number 6 here is a binomial expansion question. So in question number 6, A, we are going to try to find a term in 1 over x squared and a term in 1 over x to the power of 3. For the expansion of this, we have 2 minus 3 over x to the power of 6. Let's just expand this, okay? Then we filter out the term in 1 over x squared and term in 1 over x to the power of 3. So let's do a binomial expansion for this. It is going to be 2 to the power of 6, then plus 6 choose 1, then 2 to the power of 5 minus 3 over x to the power of 1. Okay, let me just write the 1 there, okay? So then this is going to be, next term is going to be 6 choose 2, then 2 to the power of 4 minus 3 over x to the power of 2. And let me write down one more. 6 choose 3. Then 2 to the power of 3 minus 3 over x to the power of 3. The rest of the terms I'm going to ignore because by looking at what we have here, this here is going to give me the term in 1 over x squared, and this is going to give me the term in 1 over x to the power of 3. So evaluating this using the calculator, this is equal to 64. This is minus 576 over x, and this is going to be plus 2160 over x squared, and this is 4320, in fact negative 4320. So I'm going to change this to negative. So negative 4320 over x to the power of 3, and of course there are more terms behind. So what are the two terms that the question is asking for? They are asking for this term and this term. So let me write it down. Therefore, the two terms that are required by the questions are going to be this 2160 over x squared, and the other term is this, which is minus 4320 over x to the power of 3. And the question next wants us to find the value of the constant a in that expression there, given that there is no term in 1 over x. So that b over here, which is the expression, which is going to be using this expression here, x squared plus ax multiplied by 2 minus 3 over x to the power 6. A is here. So we're supposed to find this constant a, and this is what we have. Okay, so we have an expansion of it here already. I'm going to just replace it. So this is x squared plus ax multiplied by this, which I'm going to replace it by this over here. Okay, so this over here is 64 minus 576 over x plus 2160 over x squared minus 4320 over x to the power 3, and so on. And that's the good thing about having an expansion that is like this, because it makes b sort of like easier, because we just need to now filter out another term, which is going to be the term that is there's a term that is in 1 over x. Okay, we just need a term that is in 1 over x, and especially when the question says that there is no term in 1 over x. So if I can just filter out a term that is in 1 over x, I can just simply let the coefficient be equal to 0, and that is how I'm going to try to work out the value for a. So let's try to filter out the term that is in 1 over x. We have to do a bit of observation, okay? So if I were to take x squared, multiply by which of the term here will give me the term that is in 1 over x? I would say it is going to be this, right? Because if I were to take this x squared, multiply by 1 over x to the power 3, this will give me 1 over x. So let me filter this out. So x squared I want, and the other term that I want is minus 4320 over x to the power 3, because I will be expecting a 1 over x. What is another term that is going to give me 1 over x? I guess it is going to be this and this. Okay, so it is going to be when I take ax multiplied to 2160 over x to the power of 2, because x, 1 over x squared, cancelling away, I'm going to be getting a 1 over x. And for the rest of the terms, I'm going to just ignore them, because the rest of the terms will not be getting me a 1 over x. So this that is here, now I have a minus 4320 over x, and this is going to be equal to plus, here we have a 2160 over x, and for the rest of the terms, I'm going to just do a quick re-expression of this, which is going to be minus 4320, factorizing out 1 over x, plus there's an a here, I've forgotten, okay, this. So 2160a, this is going to be multiplied to 1 over x, and so on. And since the question says that the expansion of this will not have a term that is in 1 over x, like what we have strategized to do just now, I'm going to let the coefficient here be equal to 0, then it will not have the term that is in 1 over x. So by letting the coefficient, which is minus 4320, plus 2160a be equal to 0, we will be working on an expansion that is independent of 1 over x, that has no term that is in 1 over x. And this will help us to work out the value for a. A is going to be equal to 4320 divided by 2160, and this will give me a to be equal to 2. Yep, a is going to be equal to 2. Let's move on. Let's look at the last part of this question, part C. So in part C, we are supposed to make use of the value of A that is found in the previous part, part B, and we found that A was equal to 2. So let me replace this. So A here, this was equal to 2. We are supposed to find the coefficient of X in the expansion of this. So we're going to do that filtering again. So let me rewrite this, X squared plus 2X multiplied by this, which I'm going to replace it by this again. So it's going to be 64 minus 576 over x plus 2160 over x squared minus 4320 over x to the power 3 and so on. And I'm going to filter out only those terms that is going to carry x, only those terms that has x. So for the terms that has x, I guess it is going to be this multiplied by this, right? X squared multiplied by minus 576 over x squared x. I'll be cancelling them away, so I'll be getting the term that is in x. And the other term that is going to be in x, oh, it is actually pretty obvious. It's just this and this. Okay, so it will be plus 2x multiplied by 64. If I were to take this multiplied by any other terms, I'm not going to be getting the term that is in x. So for the rest of the terms, I'm going to just ignore them for this part. And what I'll be getting here is minus 576. This times this, yes, it is a term that is in x. Then we have this is 1 to 8x, yes, another term that is in x. For the rest of the terms, we will not be expecting them to be in x. So the only term that is going to be in x is going to be minus 448x. So therefore, the coefficient of x, of the term that is in x, is going to be this, minus 448. Okay, let's move on to the next one, question number 7. So in this question number 7a, we are given this equation, which is d is equal to av squared plus bv, where a and b are constants and the variables are d and v. So let me mark it down. D here is a variable. All this here, they are also variables. And by making use of the fact that we are actually going to be getting different values for that is going to be collected for d and v, let's try to think of a way to draw this as a straight line. And for the straight line that we have drawn, we are going to be making use of it to try to find the values of a and b. How can we do this? So to do this, I'm going to just divide this equation throughout by v, which will give me a d over v is equal to a v plus b. And what I'm seeing here is actually like a linear line. If I can just change my perspective and see this here as if it is y, a variable, and this here is like the gradient, then this here is like the other variable, then this here is like the vertical intercept, then we have a straight line as long as I draw a graph to represent this by going for a horizontal axis as v and a vertical axis as d over v. Then we will be getting the straight line. Assuming that the straight line, because the straight line can be one that has a positive gradient or negative gradient. Okay, so let's say it has a positive gradient. So for the straight line that I will be expecting, because this actually looks like a straight line, right? dv versus v. So for the straight line that we have the gradient, okay, let's say the gradient is m, okay? The gradient is going to be m and the vertical intercept, let's say, is going to be c. So if I can find the gradient based on this straight line on my graph, then this gradient will actually give me the value for a. So a is going to be equal to the gradient that is on the line, and b is going to be this vertical axis intercept here. So b I can obtain by finding the vertical intercept that is on this line, and that will give me the value for b. So this will be the explanation that I'll be giving to part A. You can take a look at my PDF solution. Let's move on to the next part, which requires us to draw a graph, okay? And the graph paper is actually going to be given to us also. So we'll be drawing it on here. Let's take a look at the question together. So in part B, we are given the tiger population, and we are given the values that is going to be representing the number of tigers for the different years. And for every 10 years, it's going to be represented by 1, followed by 2, followed by 3, followed by 4, starting from the year 1960 to 1969. So the equation that we are believing that the population of the tiger will be following is this equation here. N is equal to AB to the power of T. This is given to us by the question here where A and B, they are constants. The first thing that we are supposed to do is to draw a straight line. Okay, this is definitely not a straight line. So in order for us to draw a straight line that is going to be following this model over here, we are going to do a bit of manipulation. In fact, the first manipulation that I did was trying to lawn this. Okay, I did this. Okay, let me just very quickly show you. Okay, but this is not going to be how I'm going to be continuing. So what I did was I lawn this. So I'll get a ln n is equal to ln of AB to the power of t. So it is going to be ln n is going to be equal to ln A plus ln B to the power of t. So we were supposed to be having a ln n is equal to ln A plus t ln B. Okay, this was the first thing that I tried. But when I tried this, the numbers that I've gotten is not the easiest way for me. I mean, the values are not the easiest kind of numbers for me to plot it onto the graph. So I switched. So I don't know how many of you have tried this and used ln, but you can definitely do that. Okay, just be expecting a graph that is a little bit harder to plot. I would suggest doing a log. So I'm going to do it here. Log n, this is equal to log AB to the power of t. So this is going to be log n. It's going to be equal to log A plus log B to the power of t. T, I can bring it forward. So this is going to be log n is equal to log A plus t log B. So in order for me to draw a straight line for this, I'm going to go for log n versus t. Then the gradient is going to be representing, the gradient of that line will be giving us the value for log B, and the vertical axis intercept is going to be for this log A over here. So the first thing that I'm going to do is to make use of the data that is given to me by the question, which is this. Okay, and I'm going to try to transform this data by creating for myself another table. The table will be for t versus log n. So t, they are going to be 1, 2, 3, 4. So this is easy, 1, 2, 3, 4. As for log n, I'm going to do a log of 810, then after that log of 450 and so on. This will give me 290 here. Log of 810 give me this. Log of 450 will be giving me a 2.65. Then after that, we will have a 2.38. This is log of 240, and log of 135 will give me a 2.13. I'm going to try to plot this graph. Again, you can look at my soft copy solution to see my plot. But if I were to be plotting this graph for t versus log n, I will be getting a graph that is having a negative gradient. Okay, let me just very quickly show you a quick sketch. Okay, for the detailed plot, please take a look at my soft copy solution. So we'll be getting 4 points. So for these 4 points, which is this, I will be expecting myself to be getting a pretty straight line. So let's say I've drawn the best fit line and it gives me this. Okay, so this will be representing the straight line. And in the next part of the question, after I've plotted this, in the next part of the question, we are supposed to estimate the number of tigers when it is in the decade from 2000 to 2009. So if you were to look at the question, from 2000 to 2009 is not captured by the question, but the one that is the closest is for this 4. This 4 here is 1990 to 1999, which means that for the next decade, it is going to be 2000, from the year 2000 to 2000 to 2009, which means that the next one is going to be equal to 5. The next t is going to be equal to 5. So what I'm going to do is, on my plot, I'm going to find where is 5. It is going to be somewhere here. Okay, I'm going to find where is 5, and I'm going to use my plot to find what is the corresponding value for log n. And on my graph, okay, on your graph, it can be a little bit different. It can be a little bit different. So on my graph, I got this 1.87. So based on this that I have on my graph, I'm going to equate it to log n. This is going to help us to find the value for the tiger. it is going to help us to find the population of the tiger in this particular decade. So let me go for it in part 2. Based on my graph for the year that is between 2000 to 2009, this is when t is equal to 5. And that will be when I will let log n be equal to this 1.87, which means that n is going to be equal to 10 to the power of 1.87, which is going to be approximately 74.1. So this will give us the population of the number of tigers in the decade between 2000 and 2009. And for part 3, I think any logical reason is going to work. For part 3, I don't think there's one specific answer. We are supposed to give a reason why this model may not be accurate in later decades. Because I guess a lot of things can change. The tiger may not continue to follow the numbers that is going to be according to this trend. For example, let's say we realize that the number of tigers is depleting so fast, we need to apply some policies and laws to protect the tiger, and it may be possible that the tiger will start to increase in numbers again, so it may buck this trend. Okay, so giving any reason that can potentially change the trend that we are seeing for these few decades should be acceptable for the last part. Let's move on to the next one, question number 8. Shift this up a little bit more. Okay, question number 8. So in question number 8, we have a kinematics question, and we're given this equation that represents the motion of the particle. V is equal to 24 e to the power of minus t over 6, and the particle is actually the motorcyclist. So part A, we are supposed to find the time that is taken to travel from point A to point B. And according to the question, at point B, the velocity is going to be half of that is going to be at point A. So at point A is where the whole thing is going to be starting, which means that at point A, we can just let t be equal to 0, and the velocity will be 24 e to the power of 0. The velocity is going to be equal to 24. And at point B, according to the question, the velocity is going to be half. So v is going to be equal to 24 divided by 2. V is going to be equal to 12. So we are going to be letting at point B, we are going to be letting v be equal to 12, which is 24 e to the power of minus t over 6. I'm going to let this be equal to 12. So e to the power of minus t over 6 is going to be equal to 1 over 2. I'm going to ln both sides. On the left-hand side, I'll be left with this. And on the right-hand side, we'll have this. So t is going to be equal to minus 6 times ln half. In fact, ln half, we can also write it as ln 2 to the power of minus 1. Minus 1, I bring it forward. We will have t to be equal to 6 ln 2. And if I were to press this into the calculator to 3 significant figures, this is 4.16. This is part A. And then part B. We have some space here. Let me just continue. For part B, we are supposed to find the acceleration of the motorcyclist, the particle, as he passes the point B. So acceleration, it is the differentiation of the velocity with respect to time. So it is dv dt. This is equal to 24, then e to the power of minus t over 6 multiplied by minus 1 over 6 using chain rule. So the acceleration is going to be equal to minus 4 e to the power of negative t over 6. And we are supposed to find the acceleration when the motorcyclist passes point B. So at point B, time is equal to this. Okay, so at point B, the time is equal to 6 ln 2, which we have gotten from the previous part. So the acceleration is going to be minus 4 e to the power of minus t, which is going to be 6 ln 2 over 6. And if you were to just press this into the calculator, the acceleration is going to be equal to minus 2. And for part C, we are supposed to find the distance AB. Let me just keep the information about the time that is going to be at A, that's going to be at B. Okay, so at A, we know the time is equal to 0. At B, the time here that we have found is this. So let me write it down here. The time is equal to 6 ln 2. Let's make use of these two pieces of information to find the distance AB. So in part C, in order for us to find the distance, we need an expression to represent the distance. And that we can obtain by looking for the displacement. So for the displacement, I'm going to let it be s. The displacement will be an integration of the velocity. So integration of 24e to the power of minus t over 6 with respect to time. So let's integrate this. This is going to be 24, then e to the power of minus t over 6 divided by minus 1 over 6. Let's not forget about the plus c. This is going to give me a minus 144 e to the power of minus t over 6 plus c. So for the displacement, it is going to be a to b, right? So at a, t is equal to 0. So at a, t is equal to 0, and the displacement is 0 because there's no movement yet. So at a, t is equal to 0, s is going to be equal to 0 less. So let's let this be satisfying this. Let this be satisfying this, s is equal to this. So we will have a minus 144 e to the power of 0 plus c. This is going to be equal to the displacement, which is 0. This tells me that c here is equal to 144. Therefore, the displacement is going to be equal to minus 144 e to the power of minus t over 6 plus 144. And then at the point B, the time changes. The time changed to this. Okay, at B, time is equal to 6 ln 2. So let's find the displacement at B. The displacement will be minus 144 e to the power of minus t is going to be replaced by 6 ln 2 over 6, then plus 144. The displacement here is, let me see, the displacement here is equal to 72. So at A, the displacement is 0. At B, the displacement is 72. Therefore, the distance AB is going to be equal to 72. This is question number 8. Let's move on to question number 9. Question number 9, it is a circles question, and we are given this equation. X plus 2a square plus y minus a square. This is equal to ka square. And we are told that k is equal to 4 for part A and part B. So when k is equal to 4, we are looking at x plus 2a square plus y minus a square is equal to 4a square, which we can rewrite. Okay, I'm going to rewrite this as x minus 2a square plus y minus a square is equal to 2a square. So if I were to look at this equation over here, where this equation represents the equation of a circle, this circle is one that has a center. The center is going to be at minus 2a and a. And this circle, okay, let me just draw a circle, okay? This circle will have a radius of 2a. So this distance here, the radius, is going to be 2a. And the coordinates, the x-coordinate of the circle is at minus 2a. The radius is 2a. This will give us the explanation of why is it that this circle is actually going to be tangent to the y-axis. And in part B, we are looking at this same circle. We are supposed to come out with the coordinates of the points on the circle where the tangent is going to be parallel to the x-axis. So for this same circle, let me redraw it again, okay? For this same circle, where the center is at minus 2a and a. Okay, the center is minus 2a and a. The radius is 2a, and we are looking at the points where the tangent to this circle is parallel to the x-axis. So parallel to the x-axis, which means that the tangent is going to be horizontal. The tangent is going to be horizontal. And we know that tangent is going to be perpendicular to the radius. So if this were to be the radius, this is going to be 90 degrees. If this were to be the radius, in the center, this we have a 90 degrees. And what is the radius? The radius is, according to what we have discussed, 2a. So this distance here is 2a. This distance here is 2a. So what is the coordinates of, let's say, this point? It will share the same x-coordinate as this. So this point here is going to be at minus 2a. And what is the y-coordinate? So it is going to be this y-coordinate, which is a. It will go vertically down by 2a. So it's going to be a minus 2a. The y-coordinate is going to be this, minus a. As for the other point, which is here, the x-coordinate will share the same x-coordinate as the center of the circle. So for this point here, the x coordinate is going to be equal to minus 2a. As for the y coordinate, it's going to be a, then plus 2a. So a plus 2a, the other y coordinate here is going to be equal to 3a. This is for part A and B. The next part requires us to let k to be equal to 5. Okay, for the next part, k is going to be equal to 5. So I'm going to let k to be equal to 5, which means that the equation of the circle will be x plus 2a square plus y minus a square is going to be equal to 5a square. Let me rewrite this so that this can reflect the equation of the circle better. So just like what we did previously, it is going to be x minus away minus 2a, then square, plus y minus a, then square. The radius is going to be square root of 5a. And here we have this, okay, this square. We're supposed to prove that the circle is going to be passing through the origin. The origin has a coordinates of 0, 0. So to prove that the point lies on the curve, we just need to substitute into the curve and make sure that it satisfies the equation. So let's try to do that. When it is at the origin, x is equal to 0, y is equal to 0. Let's substitute this into the left-hand side of the equation. And let's see whether we're going to be getting a 5a. Let's make use of this equation. So we will have a 0 plus 2a square plus 0 minus a square. This is going to be equal to 4a square. Then this is going to be equal to a square. This is equal to 5a square. Therefore, 0, 0, which is the origin, passes through the, okay, let me just use the same phrase that the question is asking. So therefore, the circle passes through the origin, which is going to be at the point 0, 0. Part D, we are given OP, which is going to be the diameter of the circle. We want to find, in terms of A, the coordinates of the point at which the tangent to the circle at point P is going to be meeting the x-axis. Okay, we need a bit of visualization. Okay, so I'm going to just do a quick sketch for us. Okay, this is part C. Sorry, this is part C. So this is part C. Let's move on to part D. We know from part C that the circle is going to be passing through the origin. So if I were to draw the circle here, let's say, okay, this circle has the center at, okay, let me draw the center, okay. The center is going to be at minus 2a and a. And this circle is going to be passing through the origin. Let's say this is the origin, which is at 0, 0. So P is going to be at the opposite side so that it can form the diameter of the circle. So let's say P is point here. Okay, so let's say this is point P. And what the question is saying is that at point P, we need the tangent. And this tangent is going to be meeting the x-axis. So what we are going to try and do is to find the equation of the tangent at point P and see where it passes, where it passes through the x-axis. So let's say the x-axis is here. Okay, the x-axis should pass through the origin. So we are going to be looking at the coordinates of this point. Okay, and we are supposed to find this point. Okay, it's quite a bit to do. We have to strategize. Okay, the first thing that I'm going to try do is to, I guess we need the coordinates of P. Because in order for us to find the equation of this, we need the gradient of this line and we need a point that is going to be passing through, that this line is going to be passing through. So P is critical. I'm going to let the coordinates of P be, for example, XP and YP. And for XP and YP, the good thing is, because this is the diameter of the circle, so this is the radius, this is the radius, which makes this point here, which is the center of the circle, the midpoint of OP. And we know O is at the point OO. So since this is the center, that means if I were to take the x coordinate of P, which is XP, plus the x coordinate of the origin, which is 0 divided by 2, this should give me minus 2a. This tells me that xp over here, this is equal to minus 4a. I can do likewise to the y coordinates of point P plus 0. So yp plus 0 over 2, this is equal to a. This tells me that yp here is equal to 2a. So now we can find, or we have already found the coordinates of P, which is going to be minus 4a and 2a. So now with this, we can then find the gradient of the line OP. Wait, sorry, OP is here. We can find the gradient of the line OP. So let me write it down here, okay? The gradient of the line OP, this is going to be equal to, okay, I'm going to take the y coordinate minus the y coordinate, which is 2a minus 0. Then x coordinate minus x coordinate, so minus 4a minus 0. This gives me a minus half. So what is the gradient of the tangent, which is going to be perpendicular to OP? The gradient of the tangent is going to be equal to negative 1 over minus half, which is going to be actually equal to 2. So from this, we can now come out with the equation of the tangent at point P. And that will be y minus away the y coordinates of P, which is this. So y minus 2a is equal to the gradient of this line, the tangent, which is minus 1 over this. So minus 1 over 2. Then x minus away the x coordinate of P, so minus away minus 4a. Okay, so this we have y minus 2a is equal to 2 times of, this is x plus 4a. And for this, we are supposed to then find this point. So for this over here, we are going to be letting y be equal to 0 because the x coordinate is unknown, but we do know the y coordinate, which is 0. So for this, I'm going to be letting, okay, I'm running out of space. I'm going to just continue here, okay? So for this, we are going to let the y coordinate be equal to 0. So we have a minus 2a, y equal to 0. So minus 2a, this is equal to 2 times of x plus 4a. This will give me the value of x to be equal to minus 5a. Therefore, the coordinates of this point, which is what the question wants, the point where the tangent to the curve at point P meets the x-axis, we are finally there. This point here has the coordinates of minus 5a and 0. Let's move on. Let's look at the last question here in paper 2. Last question is this. So in question number 10, we are supposed to show that the area of the shaded region is that expression that is given to us by the question. And what we're going to do is to first find the area of this by making use of integration, then minus away the area of the triangle that is below. This will give us the area of the shaded region. But that is not the very first thing that we need to do. The very first thing we need to do is to locate M, the coordinates of M, because without that, we can't do any of the things that we have just discussed. So to locate M, the coordinates of M, we are going to make use of the fact that M is at the maximum point of the curve. And to locate it, let's make use of dy dx. So I'm going to make use of dy dx. For a maximum point, it is going to be equal to 0. So let's find the expression for dy dx first. Differentiating this, it is going to be 4 cosine x over 2. Then applying chain rule, differentiating x over 2 is going to be equal to 1 over 2, then minus 1, which is differentiating x. So this is going to be equal to 2 cosine x over 2 minus 1. So at point M, we are going to be letting dy dx be equal to 0 since it's a maximum point. So dy dx is equal to 0. That means we have a 2 cosine x over 2 minus 1 is equal to 0. So cosine of x over 2 is going to be equal to 1 over 2. And we know that x is going to be between 0 to pi. So the value of x that I'm going to be obtaining here, I want to take that value that is going to be between 0 to pi. Let's first work out the reference angle, which is going to be cosine inverse of 1 over 2. This is a special angle. It is 1 over 3. So x over 2 here is going to be equal to this pi over 3. Sorry, let's say 1 over 3. But anyway, this is pi over 3. So this tells me that x is going to be equal to 2 pi over 3, a number that is between 0 to pi. I don't think it is necessary, okay, I don't think it is absolutely necessary, but we should be, okay, if in general, when I try to let dy dx be equal to 0, we cannot verify that it is a maximum point. And what if this question actually has more than one stationary point, one maximum, one minimum, and maybe even points of inflection? So I think what I'm going to do here, which is, I want to say again, okay, I don't think it is necessary for this particular question, but let's try to verify whether this point here is a maximum point. So to do that, I'm going to make use of the second derivative. So I'm going to take this and I'm going to differentiate it again. d square y dx squared, this is going to be equal to 2 minus sine x over 2, then 1 over 2, okay, minus 1 when I differentiate it is going to be equal to 0. So d squared y dx squared is going to be equal to minus sine of x over 2. So at point, it may not be at point m, okay? So when x is equal to 2 pi over 3, then d squared y dx squared, this is going to be equal to minus sine of, here is 2 pi over 3, then divided by 2. So d squared y dx squared is going to be equal to minus square root of 3 over 2. This is less than 0. Therefore, I know that y is at its maximum. So yes, I know that this is going to be the value of x that is going to be at m. So the y coordinate at m, let me just write it down here. So at m, we know that the x coordinate is going to be equal to 2 pi over 3, and the y coordinate is going to be equal to 4 sine of 2 pi over 3 divided by 2 minus away 2 pi over 3. So y here is going to be equal to 2 square root of 3 minus 2 pi over 3. And I need some space to continue. So let me just write down the coordinates of m here, okay? So we have just found out, okay, let me use red color. So it is something that we have found out instead of what the question has given to us. So we know that the coordinates of m here has a y coordinate of 2 pi over 3, and the x coordinate is equal to 2 square root of 3 minus 2 pi over 3. Okay, let me erase this. So now we are ready to find the area of the shaded region. The area of the shaded region. This is going to be, I'm going to make use of integration. So a vertical line down, this is going to be at 2 pi over 3. So we are going to be integrating from 0 all the way until 2 pi over 3 for this curve, which is 4 sine x over 2 minus x. Then I will minus away the area of this triangle, which is going to be half times base times height. The base is going to be 2 pi over 3. So here we have a 2 pi over 3. The height is going to be the y coordinates of the point M. So for the height, I'm going to write it down. 2 square root of 3 minus 2 pi over 3. So let's try to integrate this over here. This is going to be 4. Integrating this, we will have a minus cosine of x over 2 over 1 over 2. Then integrating this is going to be x squared over 2. So this will be from 0 to 2 pi over 3. And for this, if I were to multiply this in, we will have a minus 2 pi square root of 3 over 3. Multiplying this to this, we will have a plus 2 pi square over 9. And for this, okay, let me simplify this a little bit, okay? So this is going to be this divided by this with a negative here. So this is going to be negative 8 cosine of x over 2 minus x squared over 2. So this from 0 to 2 pi over 3. Minus away 2 pi square root of 3 over 3 plus 2 pi squared over 9. I'm going to substitute the values in. So this is going to be equal to minus 8 cosine of this. It is going to be cosine of this divided by 2. So cosine of pi over 3. Minus away this, I'm going to substitute in. So it's going to be equal to minus 1 over 2 multiplied by x squared, which is going to be 2 pi over 3 squared. So this will be the first portion. Then minus away, substituting 0 in, we are going to be getting a minus 8 cosine of 0. Substituting 0 in, this is going to be equal to 0. So I'm going to just minus 0 here. Then minus away this is 2 pi square root of 3 over 3 plus 2 pi square over 9. And this is going to be equal to tediousness. So this is going to be minus 8 cosine pi over 3. This is going to be equal to half. So we have a 1 over 2. As for this is going to be equal to minus away 4 pi square over 3 divided by 2. So it's going to be 2 pi square divided by 4, this is 4 pi square over 9 divided by 2. So we have a 2 pi square over 9. Then this is going to be minus 8. It will be plus 8. Minus away 2 pi square root of 3 over 3 plus 2 pi square over 9. So we have 8 minus 4. That is going to be equal to positive 4. And this can be cancelled. We're going to be left with just this. So it is going to be minus 2 pi square root of 3 over 3. And guess what? This is what the question wants us to show.